A motor generator set acting as a power supply or voltage regulator for a motor control center is an electromechanical system. It comprises a DC motor, which converts incoming alternating current or direct current power into mechanical energy, and a DC generator, which converts the mechanical energy back into regulated direct current power. In this configuration, the direct current motor is operated using a separate alternating current or direct current power source. The mechanical energy produced by the motor is transmitted to the direct current generator, which generates a highly regulated and adjustable direct current voltage. This regulated voltage is then supplied to the motor control center. The motor generator set serves as a dedicated power supply for the motor control center, providing isolated, stable direct current voltage for the motor loads. The motor generator set's generator acts as an effective voltage regulator, maintaining the direct current voltage supplied to the motor control center within a narrow range regardless of load variations or fluctuations in the incoming power source. Whether the motor generator set and the hoist should be considered one load or two loads depends on the specific system design and operation. Firstly, one load. If the motor generator set is dedicated solely to powering the hoist and is not used for any other purpose, it is reasonable to consider both the motor generator set and the hoist as a single load. Secondly, two loads. If the motor generator set is used to power multiple loads beyond the hoist, or if the hoist operates intermittently while the motor generator set remains energized, it would be necessary to consider the motor generator set and the hoist as separate loads. A wiring diagram shows a typical motor generator set configuration. The alternating current power source feeds into a circuit breaker, which then connects to a transformer. The transformer steps down the alternating current voltage to the appropriate level for the direct current motor. A rectifier converts the alternating current voltage to direct current voltage, which is then supplied to the direct current motor. The direct current motor is mechanically coupled to the direct current generator. The direct current generator produces a regulated direct current voltage that is supplied to the motor control center. A control system monitors the output voltage of the direct current generator and adjusts the field excitation to maintain a constant voltage. This ensures that the motor control center receives a stable and reliable direct current power supply. Several factors influence the performance and selection of a motor generator set for direct current power applications. These factors are firstly voltage regulation, the ability of the motor generator set to maintain a stable output voltage under varying load conditions. Secondly, efficiency, the ratio of output power to input power, which affects operating costs. Thirdly, isolation, the degree to which the motor generator set isolates the direct current output from the alternating current input, minimizing noise and disturbances. Fourthly, maintenance, the required maintenance schedule and the availability of spare parts. Fifthly, size and weight, the physical dimensions and weight of the motor generator set, especially important in space-constrained environments. The choice between considering the motor generator set and the hoist as one load or two loads depends on several factors related to the system's design and operation. These considerations are crucial for accurate power system analysis, protection, and control. If the motor generator set is exclusively dedicated to powering the hoist, with no other loads connected to its output, it simplifies the analysis to treat them as a single integrated load. This is because the motor generator set's operation is entirely dependent on the hoist's demand, and their behaviors are directly correlated. In this scenario, the combined load characteristics can be used for system planning and protection settings. Conversely, if the motor generator set powers multiple loads in addition to the hoist, each load's behavior can independently affect the motor generator set's operation. The intermittent operation of the hoist while the motor generator set remains energized introduces a fluctuating load profile. This necessitates treating the motor generator set and the hoist as separate loads to accurately model the system's dynamics. Analyzing them separately allows for precise assessment of voltage drops, current flows, and harmonic distortions under various operating conditions. When the motor generator set and the hoist are considered as single load, the combined power factor can be calculated by taking into account the power factor of both the motor generator set and the hoist. This simplified approach is valid when the motor generator set is exclusively dedicated to the hoist. However, when treating them as separate loads, it becomes essential to measure or estimate the individual power factors of the motor generator set and the hoist. This is particularly important for power factor correction and harmonic mitigation. Protective devices, such as circuit breakers and fuses, must be coordinated to protect the motor generator set, the hoist, and the connecting cables. If considered as single load, the protective devices can be selected based on the combined load characteristics. However, when treated as separate loads, each component requires its own set of protective devices, carefully coordinated to ensure selective tripping and minimize downtime. Considering the motor generator set and the hoist as a single load simplifies the design and implementation of control systems. The control strategies can be based on the combined load behavior, making it easier to optimize performance and energy efficiency. However, when treating them as separate loads, more sophisticated control algorithms are needed to manage the interactions between the motor generator set and the hoist. This approach allows for more precise control and optimization, but requires a more complex control system architecture. Energy efficiency considerations also play a significant role in determining whether to treat the motor generator set and the hoist as one load or two loads. When considered a single load, energy efficiency measures can be focused on the combined system. However, when treated as separate loads, energy efficiency measures can be tailored to each component, potentially leading to greater overall energy savings. For example, optimizing the motor generator set's operation to match the hoist duty cycle can significantly improve efficiency. When the motor generator set and the hoist are treated as a single load, maintenance can be scheduled based on the combined operating hours and conditions. This approach simplifies maintenance planning and reduces downtime. However, when treated as separate loads, maintenance schedules can be optimized for each component based on their individual operating conditions and failure rates. This can lead to more efficient maintenance and reduced overall costs. When deciding whether to treat the motor generator set and the hoist as one load or two loads, it is essential to consider the impact on system reliability. Treating them as a single load can simplify the system and reduce the number of potential failure points. However, when treated as separate loads, redundancy can be built into the system to improve reliability. For example, having a backup motor generator set or hoist can ensure continued operation in the event of a failure. IEEE Standard 929.2000 provides recommended practices for the design of power systems for direct current supply. This standard covers various aspects of direct current power systems, including motor generator sets, batteries, and rectifiers. It provides guidance on system design, protection, control, and maintenance. The article Motor Generator Sets as Direct Current Power Sources by Alice Chalmers provides a comprehensive overview of motor generator sets and their applications in direct current power systems. This article covers the design, operation, and maintenance of motor generator sets, as well as their advantages and disadvantages compared to other direct current power sources. The information provided offers valuable insights into the practical aspects of using motor generator sets in various industrial and commercial applications. When selecting a motor generator set for a specific application, it is essential to consider several factors to ensure optimal performance and reliability. Firstly, the power requirements of the load. The motor generator set must be capable of supplying the required voltage and current to the load under all operating conditions. Secondly, the voltage regulation requirements. The motor generator set must maintain a stable output voltage within the specified limits, regardless of load variations. Thirdly, the efficiency requirements. The motor generator set should be energy efficient to minimize operating costs. Fourthly, the environmental conditions. The motor generator set must be able to operate reliably in the expected environmental conditions such as temperature, humidity, and altitude. Fifthly, the maintenance requirements. The motor generator set should be easy to maintain and service, with readily available spare parts. Direct current motor generator sets offer several advantages over other types of direct current power supplies. These advantages are firstly, isolation. Motor generator sets provide electrical isolation between the alternating current input and the direct current output, which can improve system safety and reduce noise. Secondly, voltage regulation. Motor generator sets can provide excellent voltage regulation, maintaining a stable output voltage under varying load conditions. Thirdly, reliability. Motor generator sets are generally very reliable and can operate for many years with minimal maintenance. Fourthly, flexibility. Motor generator sets can be easily adapted to meet specific voltage and current requirements. However, direct current motor generator sets also have some disadvantages. These disadvantages are firstly, efficiency. Motor generator sets are generally less efficient than solid-state direct current power supplies. Secondly, size and weight. Motor generator sets are typically larger and heavier than solid-state direct current power supplies. Thirdly, noise. Motor generator sets can generate noise due to the rotating machinery. Fourthly, maintenance. Motor generator sets require periodic maintenance, such as lubrication and brush replacement. When troubleshooting a direct current motor generator set, it is essential to follow a systematic approach to identify the root cause of the problem. Firstly, check the input power supply. Ensure that the alternating current input voltage is within the specified limits and that the circuit breaker is not tripped. Secondly, inspect the motor. Check for any signs of damage or overheating. Test the motor windings for continuity and insulation resistance. Thirdly, examine the generator. Check the generator windings for continuity and insulation resistance. Inspect the commutator and brushes for wear or damage. Fourthly, verify the control system. Check the control system components, such as voltage regulators and current limiters, for proper operation. Fifthly, measure the output voltage and current. Use a multimeter to measure the direct current output voltage and current. Compare the readings to the specified values. When performing maintenance on a direct current motor generator set, it is essential to follow the manufacturer's recommendations to ensure proper operation and longevity. Firstly, lubricate the bearings. Lubricate the motor and generator bearings regularly according to the manufacturer's instructions. Secondly, inspect the brushes. Check the brushes for wear and replace them as needed. Clean the commutator with a brush seating stone. Thirdly, tighten the connections. Check all electrical connections for tightness and corrosion. Tighten the connections as needed. Fourthly, clean the components. Clean the motor and generator windings and other components regularly to remove dust and dirt. Fifthly, test the insulation resistance. Test the insulation resistance of the motor and generator windings periodically to ensure that the insulation is in good condition. The application of direct current motor generator sets in elevator systems highlights their role in ensuring smooth and reliable operation. In elevator systems, the direct current motor generator set provides a stable and controlled direct current power supply to the hoist motor, which drives the elevator car. The direct current motor generator set's ability to regulate voltage and current is crucial for maintaining consistent elevator speed and minimizing jerky movements, enhancing passenger comfort and safety. The direct current motor generator set also isolates the elevator system from fluctuations in the incoming alternating current power supply, preventing voltage dips and surges from affecting elevator performance. This isolation is particularly important in buildings with sensitive electronic equipment, as it minimizes the risk of interference and damage. In addition to providing a stable power supply, the direct current motor generator set also offers regenerative braking capabilities. When the elevator car descends, the hoist motor acts as a generator, converting the potential energy of the car into electrical energy. This energy is then fed back into the direct current motor generator set, which can either dissipate it as heat or, in more advanced systems, feed it back into the building's power grid, improving energy efficiency. The use of direct current motor generator sets in elevator systems is a well-established practice, with many older elevators still relying on these systems for their operation. While newer elevator systems often utilize solid-state direct current drives, direct current motor generator sets remain a viable option, particularly in situations where reliability and isolation are paramount. Proper maintenance and periodic inspections are essential for ensuring the continued safe and reliable operation of direct current motor generator sets in elevator systems. These measures include checking the condition of the brushes, commutators, and bearings, as well as verifying the integrity of the electrical connections and control systems. In conclusion, direct current motor generator sets offer a reliable and versatile solution for providing direct current power in a variety of applications. Their ability to isolate, regulate, and provide regenerative braking capabilities makes them well suited for demanding applications such as elevator systems. While newer technologies have emerged, direct current motor generator sets remain a valuable option, particularly in situations where reliability and isolation are critical.